The computer, such a wonderful machine. When you use a mouse and keyboard, you make things happen on a screen. It can figure out hard sums, or help you write a book about how you shop for frogs online or find a recipe to cook. You can play a game, design a hat, or compose a jaunty tune. It can help you create art or plan a voyage to the moon. It can help you keep in touch with friends you haven't seen in years, or send an email to your dad to share your greatest fears. The computer does it all, I thought, and I gave a little smirk. But I do have one small question. How does this bad boy work? Who on earth could tell me? I think I need a tutor.
Then maybe I can help,
exclaimed my friendly old computer.
There are 3 steps that I go by whenever I compute. I take input, which I process to arrive at an output. Input might be a mouse click or you typing in a sum. I'll process what you give me and return you the outcome. Imagine, if you will, some electricity. A pulse which travels down a wire and works its way through me. The flow of electricity, or a current, as it's known, is an essential part of any old computer you may own. See, any substance through which electricity can flow goes by the name conductor, such as metal, don't you know? On the other hand, a substance where a current cannot go is called an insulator, such as glass or a rubber toe. And then there are some substances which sometimes will condone a current passing through them, for example silicone.
Silicone? Isn't that what a clown eats ice cream out of?
Silicon,
my computer said. She's such a good instructor.
Is a type of substance scientists would call a semiconductor. The silicon is used to make a gate called a transistor. Switching on and off the current's flow, my silly mister. On and off and off and on, the transistor keeps on going.
But how does this explain how our computers seem all-knowing?
Computers do all their counting using only 1 and 0. It's a system known as binary, my favorite blue-haired hero. The transistor switches on and the computer sees a 1. When it switches off, it sees a 0, nada, none. If you combine transistors, all these zeros and funky ones can be put together in a way that can calculate hard sums. No matter what you want to do, the computer can convert the problem into binary and then it sets to work. You click the mouse's button, then a signal will go through, describing where the mouse was and what you wanted to do. Using only 1s and 0s, the machine will understand what to do with every mouse click, key press or command. It's a bit like a secret code, where different combinations of 1s and 0s can be used to share communications.
But what happens to the 1s and 0s? Do you send them on a trip?
I carefully direct them to the correct microchip. The basic input-output subsystem, or BIOS as it's known, decides what your intention was and makes sure that it is shown to a central processing unit where it will retrieve information from its memory, gets instructions, and would you believe it processes and it calculates, and before you can shake your foot, it passes what it needs to the relevant output. The output could be many things like showing an image on a screen, or playing a sound, or printing out a picture of a jumping bean, the monitor and printer and the speakers that it chooses. Understand the language that this jazzy old computer uses.
I said, and thank you for trying to explain how computers work, but it's confusing in my brain.
Don't worry,
the computer said.
You actually don't need to understand my inner workings to use me, I concede. Programs and operating systems translate my binary thinking into something humans understand faster than blinking.
Well, that's some good design, I thought. I'm glad you told me that. It means anyone can use one, and I gave the machine a pat.
So what would you like to do today?
Asked my binary appliance. The same thing I do every day. Let's do some brilliant science.